Hello Java developers! Today I have the pleasure to talk to you about one of the most exciting features of MicroProfile. It's MicroProfile Fault Tolerance. And the reason behind that is because with MicroProfile Fault Tolerance, you can handle failures between two or more microservices communication. And to demo that, let me show three microservices implemented using MicroProfile. I have here a microprofile called customer that calls another microprofile called preference and another one that calls recommendation. What I did in the recommendation endpoint was to alternate between a response that will take 2 seconds to reply and misbehave, returning an error, a service unavailable. So let's see that happening. When I access the recommendation straight to the port 8082, we can see that or it will return an error or it will take 2 seconds to reply. And it will keep that way. So it's an error or 2 seconds to reply, or an error or 2 seconds to reply. So what we or users usually do when there is an error? Well, we keep forcing retries and retries and retries. And that will cause not only this method to become slow, but the whole microservice will become slow. One way to avoid this overload is by using a bookhead. So what is a bookhead? So the bookhead were used inside ships to avoid a flooding in a compartment to flood another compartment. So we can see here in a diagram, if something crashes in the front of the ship, only the bookhead, only the compartments A, B, C, and D will be flooded. The bookhead will avoid the flood to go to other compartments. And that's what we will do using the bookhead pattern in the microservices. If we look at the documentation of MicroProfile fault related to bookhead, we will see that the bookhead pattern is to prevent faults in one part of the system from cascading to the entire system, which might bring down the whole system. The implementation is to limit the number of concurrent requests accessing to an instance. Therefore, bookhead pattern is only effective when applying the bookhead annotation to a component that can be accessed from multiple contexts. So what we will do here is to place the bookhead annotation in our recommendation endpoint. This value 5 will prevent more than 5 requests in this endpoint. Let's try it. Now that I have recompiled and run my microservice, let's try to invoke my microservice once. That keeps working. So count number 1, then an error. So let's perform a series of refreshes. We can see here that with more than 5 requests, it will throw a bookhead exception, where as we can see here. So no more than 5 requests are allowed in this microservice. But we can continue calling this microservice from other microservices. For example, I implemented the bookhead in the recommendation, but if I continue using the chain customer preference and recommendation, I still have the pattern, an error or a delay, an error or a delay. So to avoid this behavior, what I will do is to implement a circuit breaker pattern. So what's the purpose of a circuit breaker? We can see here in this example where the product service will request the price for a product. So it will request for the circuit breaker that will perform the call. And if there is a connection issue, the issue will be detected. And if the threshold is reached, then it will trip the circuit to be opened. And then the product service will know that the connection to price service is failing. In that case, in a second attempt, the circuit is already opened, and instead of going to the price service, it can consume the price from the cache service for the price. And it's good also to know that a circuit breaker has states. So when everything's normal, when the communication is flowing, the circuit is closed. And if it starts to getting errors, if the microservice B starts to get to throw errors, and if that error limit is reached, then the circuit is opened. Of course, it will not keep that way forever. So after a certain amount of time, the circuit will be half open, which means that it's in an unknown state. We don't know if the service B is working or not. So it will try another request that can be succeed. In that case, the circuit will be open, will be closed. And if this request fails, then the circuit will be kept open again. So to implement a circuit breaker, we can go to our preference endpoint and use the circuit breaker annotation. In this case, I'm saying in 4 requests, if the failure rate is more than 50% of the requests, if I do 4 requests and more than 2 are failing, that will trigger the circuit to be open. Of course, I can also say how much is the delay to place the circuit in a half open state. The default is 5. Or I can use also the success threshold. The success threshold is the number of successful executions before half open circuits closed again. The default is 1, so I will not use this. Let's see how is the behavior using a circuit breaker and performing the invocation in the chain customer preference and recommendation. So first one is error, then a delay, then an error, then a delay, then an error. And if I keep refreshing, look here that it does not take so long anymore to return an error. It's failing fast. That's because the connection is not going through the service to the recommendation service. That's because the circuit is opened. We can see it here. Let me perform a series of requests, and then we can see here the circuit breaker exception. History circuit short-circuited and it's opened, and the circuit is opened. That's why I'm returning failing fast. And of course, avoid to, as I presented here, where instead of just failing, we can request an exception from another service or promote an alternative path. I can create here a fallback to that method. So if I use the fallback method and say what method will be invoked in a case of failure, I can provide a response fallback method or anything that I want in a case of failure. Let's see that happening by compiling the project again and now making my circuit to trigger opened state. Yeah, now we can see fallback method. It's giving me that the circuit were opened, then it after 5 seconds it became half open. I tried again, it closed, and so I got the response, but the circuit is opened again, and I'm getting a fallback error, a fallback method being invoked. Another thing that I can do with MicroProfile Fault Tolerance is to use the timeout annotation. The timeout annotation can specify how long this method can take to execute. In this case, I said that it will take 500 milliseconds or half seconds to execute. And I can even force here, for example, this method will take 10 seconds before calling the next microservice. And note here that this invocation will never happen because the timeout exception will be thrown and the fallback method will be executed. So let me run this again. And note here that the method takes only half seconds to execute. So I'm always falling in the fallback method because the timeout exception is being handled. What I want to do is, instead of making this microservice recommendation fail or take 2 seconds to reply, I will make it fail and work, fail and work. And instead of doing everything like I did here with a circuit breaker or a fallback or a timeout, I will use the retry annotation that will retry 5 times before giving up. So let's execute and see how my microservice behaves with the retry annotation. But if I go to the chain, the invocation chain where customer invokes preference and invokes recommendation, I'm always have the recommendation replying okay. That's because preference will retry the connection to recommendation in a case of failure. So all those failures here are being ignored. We can see here that in a case of failure, it returns a 503 status. So that's why the preference knows that the recommendation is failing and retries at least for 5 times before saying throwing an exception. And again, in a case of exception, I can use a fallback method. So I hope that you enjoyed this tip. It will really help your microservices to be fault tolerant. And the source code that I used is in the description of this video, as the credits for the image that I used during this presentation. Follow me on Twitter for more tips like this, and see you in the next video. Bye bye.